Birth and death. The phenomenon of normality leading to evolution of the living present and survival of the future. Earth's ecosystem supports an amazing diversity of species. Scientists have identified and named approximately 1.7 million species, but the task is not yet even near its completion. Over evolutionary time, new species evolve, while existing species become extinct. There have been dramatic, long-term evolutionary changes in patterns of global diversity as a result of speciation and global extinction. Over the past 600 million years, the Earth's biodiversity has been increasing. Among most groups of organisms for which data exists from the fossil record, the number of species has increased continuously since the taxonomic group first appeared in the fossil record. The diversity of our planet is a story of constant change.
There have been 5 major extinctions in the history of the planet. There's the Ordovician, the Devonian, the Permian, there's the Triassic-Jurassic, and the Cretaceous-Tertiary, the one that killed all the dinosaurs. This series of events are believed to have caused the extinction of more than half of all species inhabiting the Earth. 65 million to 125 million years ago, in the late Cretaceous period, an asteroid striking the Earth had led to the interruption of oceanic circulation, alteration of climate, and tremendous volcanic eruptions. Another notable extinction event occurred during the Pleistocene epoch, spanning the world's recent period of repeated glaciations or ice ages. Erratic changes in climate had caused the extinctions of a great number of mammalian life, such as the woolly mammoth, mastodon, giant deer, giant sloth, and saber-toothed cat. On the other hand, since 1600 AD, a great number of present-day extinctions have taken place, in which humans are the main culprits, causing more than 75% of these extinctions through habitat distractions.
Across the Earth's surface, life is not distributed equally. There are distinct geographic patterns of species richness. In general, the number of terrestrial, freshwater, and marine species decreases as one moves away from the equator towards the poles. However, the actual underlying pattern of gradients in species richness is often much more complex and usually disrupted by other variables such as topography and climate. For instance, although vascular plants follow the general trend for species richness relating to latitude, there are still a number of significant deviations from the trend that can be observed when the data are viewed in the longitudinal perspective. Note the 2 latitudinal diversity peaks in the longitudinal belt that includes the continents of Europe and Africa. One peak is associated with the equatorial region, while the other in mid-latitudes of the Mediterranean. Deviations from the general latitudinal gradient of species richness are also observed for certain taxonomic groups, like the family Cactaceae, which are exclusive only to environments with permanent zone of high pressure and low precipitations. Although scientists do not know the exact mechanisms underlying the geographic pattern of species diversity, more than 25 different mechanisms have been proposed, including the age of community, stability of the climate over time, spatial heterogeneity of the environment, and ecosystem productivity. Among the various hypotheses proposed, the most easily interpreted are those relating to the availability of environmental energy or thermal energy associated with the environmental features such as climate and the availability of essential resources. It was found out that species richness of terrestrial vertebrates is correlated with potential evapotranspiration, which is an integrated measure of energy input to the ecosystem. Regionally speaking, plant species richness is correlated with actual evapotranspiration, which is an index that includes both the flux of thermal energy and water availability for evaporation. On the other hand, geographic patterns of species diversity in marine environments are correlated with mean sea surface temperatures. In terms of ecosystem productivity, geographic patterns of both terrestrial plants and animals are found to be positively correlated to net primary productivity. Like patterns of species richness, terrestrial net primary productivity also decreases with increasing latitude. However, the general pattern for marine environments appears to be opposite. Patterns of species diversity for marine organisms are inversely related to ocean primary productivity. This is because latitudinal patterns of diversity in marine environment appear to be influenced by seasonality of primary productivity rather than by total productivity.
There have been 5 major extinctions in the history of the planet. There's the Ordovician, the Devonian, the Permian, there's the Triassic-Jurassic, and the Cretaceous-Tertiary. Is the 6th extinction already on its way, or is it already here? This is a story of a constant change.